This is an introductory video tutorial of the JetPlanner 4.0, which is a powerful simulation tool for laying telecommunications and energy cables and underground ducts or on rollers. In that tutorial, we will simulate the feasibility of the installation of a single core energy cable of a diameter 89 millimeters on a distance of 834 meters on rollers and duct stretches with a 3 tons winch and 2 6 tons pushers positioned along the trajectory. So, to start the JetPlanner 4.0, you must first start your browser. Type in the URL you received in the confirmation email from Plumettaz, jetplanner.plumettaz.software. Enter your username or your email in the login field, along with the personal password you received directly by email. Then, click on Login, and you arrive on the main page, which is the JetPlanner 4.0. First, you can go select the language in which you want the interface to appear. Here is the Help menu, where you can access the user guide. Or a guide that describes all the equations used in the application. A user manual that explains here how to draw a trajectory in Google Earth to import it in KML format into the JetPlanner, and a description of what is the coefficient of friction between the cable and the duct and how to determine it. And finally, the release notes of the JetPlanner 4.0 application. In your profile, you can also modify your personal information as your username, full name, and email address. You can also edit the system of units, selecting, for example, the standard system of units. We return here to the home page, which lists all the projects you have worked on. The first time you open the application, you can click here on this button to create your first project, and then you can type here the name of your project with the customer's name, the location, the date, and the optional description of the project. You can then add an image here to easily identify your project among all the projects you will create later. Click on Save button to validate the changes. You are now on the project page. First, it is possible on this page to load different files like the cable characteristics so you can easily find them during the project. Duct characteristics may be a feasibility study of the project or a trajectory obtained via AGIS systems or Google Earth. We can now simulate the cable installation feasibility of a first section. In a project, you could simulate several successive sections or compare similar sections with different parameters. In this specific case, we will simulate a single section, but there could be multiple cable sections in a project. To create a section, click on New Section. We will now configure the various parameters to simulate the feasibility of cable laying for the trajectory presented at the beginning of this video. The first thing to do is to type a name for this section, and we can add a description of this first section. And then we will choose the cable installation method. So here, I will scroll with the mouse over the different methods. The tool allows simulating cable installation using a pusher to push the cable in a duct, or by pulling the cable with a winch in a duct or on rollers, or a combination of both push and pull methods. Then the jetting method, where we push a cable into a duct by injecting pressurized air, which makes it easier to install the cable over longer distances. A similar method, named floating, using water instead of air. And the water push-pull method, which allows simulating the installation of a power cable with Plumettaz's WaterCab. Free-floating, also a method with WaterCab that allows pushing cable segments into a duct using pressurized water that is very useful for installing power cables in offshore wind farms. In our situation, we will simulate the installation of a power cable on rollers and in duct segments using the pulling method as previously presented. Once we have selected the different parameters, we see that the first step is validated in green, confirming that the parameters are coherent. We can then move on to the second step by clicking directly on equipment to choose the machine we will use for the cable installation. In our case, we will choose a TL3000 series winch. Once the machine is selected, the different parameters appear below. The next step is to configure the different stretches in which the cable will be installed. In our example, there are two different types of stretches, one on rollers and the other one in a duct. Let's start by editing the parameters of the first stretch, selecting the stretch type rollers and a constant spacing of 6 meters between rollers. This section is identified in blue. The second stretch of the simulated section is installed in a duct. Click on Add Stretch. Edit the name of this stretch. Select the duct type of stretch. Enter the outer diameter of the duct and the internal diameter. And finally, the specific coefficient of friction between the duct and the cable. According to the installation, the cable can be installed in one stretch or a mix of several stretches. Once the stretch settings have been configured, you must now configure the settings for the installed cable. Select the industry and type of cable, a single core power cable in our case. The cable diameter is 89 millimeters, and the maximum pulling force supported by the cable is 30 kilonewton. An interesting option is to click on the Expert View mode to access much more settings, such as the name of the cable, so that it can be easily identified, or replacing the estimated linear weight of the cable with the value specified in the technical specifications. And why not the minimum bending radius that the cable can withstand. This expert mode is therefore reserved for experts who are familiar with cable laying theory and do not need the assistance provided by the automatic functions of this simple mode. You can also click the yellow star to the right of the fields to add your important fields to the favorites in the simulation menu. We will see the advantage of this in the chapter on result simulation. The application also checks the validity of the values you edit. Let's take a simple example with the editing of a cable diameter that is almost equal to the inner diameter of the duct in which it will be installed. An orange warning is then displayed with an explanation of the reason for the warning below the relevant field. With a warning, the application detects an inconsistency in the parameters, but the simulation is still possible. And if I increase the cable diameter again, this time to a diameter greater than the inner diameter of the duct, the error turns red because the simulation is no longer possible. The reason is also displayed below the concerned field. But let's return to the correct base value to continue this simulation. Before changing the menu, look at the information icon to the right of the Edit fields. If you click on it, you will find information about the field and the value to be edited. Now we have to edit the trajectory along which the cable will be installed. There are two methods for editing a trajectory. The first is to import a file containing the trajectory coordinates, which is quick and easy. This method will be explained later. The second method involves creating the trajectory segment by segment. This takes longer, but allows you to create all types of trajectories. We will now find out how to proceed with our project. First, the trajectory starts at an angle of 180 degrees. Click on Add Segment to create a segment to specify which type of section to use for the next segments. Select the segment type stretch and choose the previously edited stretch named on rollers. Click on Create Segment. This stretch is identified in blue, as we defined earlier when creating the stretches. All subsequent segments will therefore be identified in blue. Click on Add Segment to create the first segment of our trajectory, which is a straight horizontal line of 50 meters. Click on Add Segment to create the curve that follows this first segment on the right. Select Roller's Curve, then edit the horizontal angle to -90 degrees and a curve radius of 6 meters. Then create this segment. The next segment is a straight line of 165 meters. Here we see the first 4 elements in blue, which correspond to the sections laid on rollers, with the last 165-meter segment highlighted, which can be seen in the top view and profile views. After the 165-meter segment, there is another curve on rollers with an angle of 45 degrees, still with a radius of 6 meters. Then a new horizontal right segment of 15 meters. This first blue section ends with a curve on rollers at an angle of 45 degrees and a radius of 6 meters. And you can see all these first segments of the blue section installed on rollers on the 2 graphs showing the profile view and the top view. Note that there is no elevation for this cable installation carried out on flat horizontal ground. We will now switch to the section of cable installed in a duct, which we previously created and identified in red. We therefore create a new stretch, which we have named in duct and identified in red. All future segments created will now be identified in red. Now you need to create a horizontal straight segment 23 meters long. The rest of the trajectory is once again placed on rollers. You must therefore reselect the stretch on rollers in blue for the rest of the trajectory. At the outlet of the duct, there is a roller curve at a 45-degree angle with a radius of 6 meters. Then, a horizontal straight segment of 15 meters. We will stop here for this example. Remember that you can view the entire trajectory at any time on the profile and top view graphs. Here, you can see the 2 stretches on rollers in blue and the stretch in a duct in red. To save time, you can import a trajectory file directly. As in this example, this can be a KML file created from a GIS system or from Google Earth. By selecting the KML file, the trajectory is imported directly into the application. It is therefore no longer necessary to manually create all the segments, as described before. Here at the bottom, on the Information menu, you can view various information, such as the total distance of the trajectory and the total angles of the trajectory, to get an idea of the difficulty of the cable installation. However, the 2 intermediate pushers must still be added to this trajectory. To do this, select the segment in front of which the pusher will be added, segment 5 in our example. Then add a line by selecting Insert Row. Select the type pusher, then the DF6 pushing machine, and edit the applied pushing force to 6,000 Newton. Repeat the same operation to place the second pusher before segment 18, editing the same values. All the values displayed for the different segments can be modified later, as can be seen here on segment 17. However, we will not apply any changes at this time. The final step before simulating the cable installation is to constrain the simulation, such as the speed of cable laying, the maximum pulling force of the cable, or the loss of force due to the unwinding of the cable drum. It is still possible to adjust some parameters of the simulation, such as the ability to display the radial force density exerted on the cable in the trajectory curves, in order to ensure that the cable will not be damaged. Once all the parameters have been correctly edited, it is then possible to view the simulation result. First, you will find a window with messages here. The window that displays the results. The favorites that have been previously selected. Then the main graph displaying the simulation result with the elevation profile and the top view. Let's start with the window containing information messages and warnings. In this case, the first line shows the recommended amount of lubricant for installing this cable under the right conditions. The results window shows in green that cable laying is possible for this trajectory, and the parameters entered, over a total distance of 834 meters and a duration of 42 minutes. The favorites window displays all the parameters selected as favorites, which can be modified to immediately view the impact on the results chart. And finally, the results graph window shows two mains lines. The red line indicates the maximum force at which the winch can pull the cable, and the blue line shows the built-up force necessary to pull the cable along this trajectory. It is interesting to note that these two drops in force represent the action of the two pushers positioned along the trajectory. As for the increase in force at this point, it is due to the capstan effect of the cable in this 90-degree turn. The advantage of displaying favorites in this location is that you can vary them to see immediately the impact on the results graph in real time. For example, with this first parameter, what effect does an increase in the linear weight of the cable have on the installation? By increasing this value, we see that the force required to install the cable, shown in blue, increases significantly with the linear weight of the cable. And when the value exceeds 22 kilograms per meter, the blue line crosses the red line and the results window turns red, indicating the cable will be blocked at 772 meters. Which means that more force is required to install this cable than the current equipment can provide. But let's return to the correct initial value. Now let's change the coefficient of friction. We can see that when we increase this value to 1, the force required to install the cable, shown in blue, increases. However, it remains possible in this example, since the blue line does not intersect with the red line. You can also vary the direction of the installation here. That is, instead of laying the cable from point A to point B, you simulate the installation from point B to point A, which can sometimes solve problems. But in our case, this does not add any value. The green line shows the radial force exerted on the cable, particularly in the curves, which is the result of the capstan effect. Let's now look at the effect of cable stiffness on the installation. The value in light gray in this field has been automatically estimated by the application based on the parameters entered. Increasing this value has no significant impact on the installation, but decreasing it quickly leads to cable blockage, at a distance of 562 meters in our example. This button, available on certain fields, allows you to calculate the automatic value proposed by the application based on the parameters entered, which is very useful when the value is unknown. Now let's reset the original settings before continuing. We will now modify the pulling force of the two pushers that have been added to the trajectory in order to see the effect they have on the feasibility of this installation. You can change the value of the first pusher on segment 5 by clicking on this symbol to enter a value of 0 Newton. Then let's do the same for the second pusher located on segment 18. Let us now return to the simulation window to see the impact of removing the pushing force of these two intermediate pushers. The results window remains green, and the blue line remains below the red line. This means that these two pushers are not necessary for installing this cable along this trajectory. Once this is done, we can move on to creating the cable installation report. The report options can be edited, such as displaying the results at the top of the report. This report contains all the parameters and information edited, with each segment of the route, then the graphs of the results, with profile and elevation views of the trajectory. At the bottom of the report, there is even a bill of material needed to carry out this installation, including the machines, the number of straight and curve rollers, and the amount of lubricant required. To share this report with another person, whether a colleague or a client, simply click on the Share Section button at the top of the page, then edit the recipient's email address before clicking on Send Email. And before leaving the project, never forget to save the section to memorize all the edited settings. Once the simulation is complete, you can return to the main page where your first project is located. You can then add all your future projects there. Thanks for your attention and enjoy your experience with JetPlanner 4.0.